So in this video, we are going to learn how to find the bearing of a point from another point and how to calculate the distance between 2 points. Now, before we get into today's lesson, let's briefly explain what bearing means. Bearings give direction in terms of angles, and there are two kinds of bearings we are going to talk about in this video. We have the first one to be the compass bearing, and then the 3-figure bearing. Now, for the compass bearing, it is based on the 4 main cardinal points, that is the north, the south, the east, and the west, and its angle is measured from the north. So for example, if you are asked to represent north 50 degrees east, then you can draw the compass. You have the north, the east, the south, and the west. So north 50 degrees east means that we are going to take the measurement from the north 50 degrees to the east. So this is how to represent north 50 degrees east on the compass. For instance, if you are asked to represent south 60 degrees west, then from the south you are going to move 60 degrees to the west. So this is 60 degrees, and this is how to represent south 60 degrees west on the compass. Now let's move on and talk about the 3-figure bearing. So the 3-figure bearing is an angle measured in degrees. It is also measured in the clockwise direction from the geographical north. So keep this. Always, bearings are measured from the geographical north. Bearings are always measured from the geographical north. And then the angles are given in 3 figures, from 0, 0, 0 degrees to 360 degrees. So if you are given 90 degrees, then in 3-figure bearing, this is equal to 090 degrees. If you have 60 degrees, then that is equal to 060 degrees. Now in the next section, we are going to solve these two questions, and then we are going to talk about the sine rule and the cosine rule and how to use them to find the bearing of a point from another point and the distance between 2 points. Now let's solve these two questions. Question 1. If the bearing from O to A is 40 degrees, find the bearing of O from A. If the bearing from O to A is 40 degrees, find the bearing of O from A. So let's draw our compass. So we have the north, the east, the south, and the west. So this is our reference point, that is point O. And we are told that the bearing from O to A is 40 degrees. So we are going to take our direction from the geographical north 40 degrees in the clockwise direction. Now let's draw a line connecting O and then A. So this is point A, and we have the bearing to be 40 degrees. So this is the bearing from O to A, 40 degrees. Now we are going to find the bearing of O from A. So this time A becomes the reference point. Now let's label the cardinal points. We have the north, the east, the south, and then the west. So to find the bearing of O from A, we are going to take the direction from the geographical north at point A in the clockwise direction to hit the line connecting OA. So from the north in the clockwise direction, this is 90 degrees plus another 90 degrees plus this angle. Now to find this angle, these are alternating angles. So if this angle is 40 degrees, then this angle is also 40 degrees. Therefore, the bearing of O from A is 180 plus 40, which is 220 degrees. So we have our answer to be 220 degrees. Now let's solve for question 2. We are told that the bearing from O to C is 210 degrees. What is the bearing of O from C? Here is supposed to be from C. So what is the bearing of O from C? So now let's represent the first statement in the diagram form. That is the bearing from O to C. So assuming that this is point O, we have point O here, and then this is the north, the east, the south, and the west. The bearing of O to C is 210 degrees. So from the geographical north in the clockwise direction, this is 90, 180, and then between 180 and then 270, we have 210. 210 minus 180 is 30. So it means that the small angle here will be 30 degrees. So we are going to add 30 to 180 to give us the 210 degrees. So this is 30 degrees. And this becomes our point C. So this is point C. Now because these two angles are alternating angles, it means that this angle is also 30 degrees. Now if you want to find the bearing of O from C, now C becomes our reference point. So from the geographical north in the clockwise direction to hit the line connecting O and C, so this becomes the bearing of O from C, that is 30 degrees. So generally, if the bearing of B from A is theta degrees, then the bearing of A from B is equal to I, theta plus 180 degrees if theta is less than 180 degrees, and then II, theta minus 180 degrees if theta is greater than 180. And that is very clear here, because in question 1, the bearing from O to A is 40 degrees. Now because theta, which is 40 degrees, is less than 180, then the bearing of O from A becomes 40 plus 180, which is 220 degrees. In the second question, the bearing from O to A is 210 degrees. That is the value of theta. Now because theta is greater than 180, then the bearing of O from A becomes theta, which is 210 minus 180, and then we have the answer to be 30 degrees. Now let's talk about the sine rule and the cosine rule and how to use them to find the bearing of a point from another point and the distance between 2 points. So given a triangle with sides A, B, and C, and then this triangle has angles capital A, capital B, and capital C. Then according to the sine rule, sine of angle A divided by the opposite side of the triangle, that is side A, is equal to sine of angle B divided by opposite to the angle B, that is side B, and that is also equal to sine of angle C divided by the opposite side, which is side C. Now you can either use any two to find the side or the angles of this triangle. So this is what you call the sine rule. Now let's move on to the cosine rule. The cosine rule. Now from the same triangle, according to the cosine rule, A square, which is the longest side, is equal to B square plus C square minus 2 times B times C cosine of the angle A. So the square of the longest side, which is A square, is equal to B square plus C square minus 2 times BC cosine of the angle A. Now if A is equal to 90 degrees, then cosine of angle 90 degrees is equal to 0, which make this term go to 0. Therefore, the equation reduces to a square equals b square plus c square, which is the Pythagoras theorem. So when the value of angle A is 90 degrees, then this cosine rule reduces to the Pythagoras theorem. Now that we are familiar with both the sine rule and the cosine rule, we can take some examples on bearing and distance problems. So for question number 1, an aircraft flies 50 kilometers on a bearing of 215 degrees and then 75 kilometers on a bearing of 125 degrees. Calculate the distance and the bearing of the end of the journey from the starting point. We are going to calculate the distance and bearing of the end of the journey from the starting point. Now let's solve this question together. So from the question, we are told that an aircraft flies 50 kilometers on a bearing of 215 degrees. So we are going to consider the starting point or the initial point of the aircraft to be point A. So assuming that this is point A and this is our north, so we are going to take the bearing 215 degrees. So from the geographical north in the clockwise direction, this is 90 degrees, and then this is 180. Now 215 minus 180 is 35. So we have 35 degrees here. So the aircraft moves from point A to point B. So this is point B, 50 kilometers from point A. Now because this angle is 35 degrees, this angle is also 35 degrees because they are alternating angles. And then also from point B, the aircraft flies 75 kilometers on a bearing of 125 degrees. So from point B, this is the north. So from the geographical north, this is 90 degrees. 125 minus 90 is 35. So we have an extra 35 degrees here. And then the aircraft flies from point B to point C at a distance of 75 kilometers. So let this be point C, and this happens to be the end point of the journey. So the whole of this angle is 125. This is 35 degrees. Now let's close the triangle. Now to the question. We are going to calculate the distance and the bearing of the end of the journey from the starting point. In other words, we are going to find the distance AC and the bearing of C from A. Now before we find the distance and the bearing, let's sort out with the angles. Now the whole of this angle is 90 degrees. So 90 minus 35 is 55. So this angle is 55 degrees. 55 plus 35 is 90. So it means that the whole of this angle is 90 degrees. Now since one of the angles of this triangle is 90 degrees, then we can use Pythagoras theorem to find the distance of the longest side, AC. So that is going to be the distance of the end of the journey from the starting point. So the distance AC square is equal to AB square plus BC square. So AC square is equal to AB square plus BC square. We have distance AB to be 50 kilometers. So 50 square plus we have BC to be 75 kilometers, so 75 square. 50 square is 2,500. 75 square is 5,625. So when you add the two, you have 8,125. Now the distance AC is equal to the square root of 8,125, and this is equal to 90.1388 kilometers. So we can leave this in two decimal places as 90.14 kilometers. So this is the distance of the end of the journey from the starting point, the distance AC. Now let's find the bearing of C from A. That is the bearing of the end point from the starting point. Now the bearing of C from A is this angle. Therefore, it is 180 minus the value of this small angle. 180 minus the value of this small angle. Now to find the value of this small angle, we are going to use the sine rule to find the value of this whole angle. Then we can subtract 35 from the full angle, and then we can subtract that value from 180. So we are going to use the sine rule to find the whole of this angle. So let the whole of this angle be angle X. So according to the sine rule, sine of angle X divided by the opposite side is 75. So 75 equals, we have this angle that is 90 degrees. So sine 90 divided by opposite to this angle is side AC, that is 90.1388. So we can cross multiply here, and then we have 90.1388 sine X equals, but sine 90 is 1, so we have 75 times 1, which is still 75. And then we divide through by 90.1388, 90.1388, and then we have sine X to be equal to 0.8321. So X is equal to sine inverse of 0.8321, and then we have X to be equal to 56.3 degrees. So that is the value of this full angle. That is the value of this full angle, 56.3 degrees. Now if you want to find the value of the smaller angle, so the smaller angle is equal to 56.3 minus 35, and that is equal to, that is 21.3 degrees. So to find the bearing of the end of the journey from the starting point, we are going to subtract this value from 180. Therefore, 180 minus 21.3 is equal to 158.7. So this is the bearing of the end of the journey from the starting point. Now let's take the second question. Now let's solve the second question, question 2. A village K is 12 kilometers from a lorry station P on a bearing of 45 degrees. Another village R is 20 kilometers from K on a bearing of 165 degrees. Calculate A, the distance of R from P to one decimal place, and then B, the bearing of R from P to the nearest degree. A village K is 12 kilometers from a lorry station P. So assuming that this is the lorry station P, we have a village K that is 12 kilometers from P on a bearing of 45 degrees. So starting from P, from the geographical north in the clockwise direction, we have a village K that is 12 kilometers from P on a bearing of 45 degrees. Another village R is 20 kilometers from Q on a bearing of 165 degrees. So from Q, we are going to take the bearing 165 degrees. This is 90. 165 minus 90 is 75. So we have 75 here. To another village R. So the whole of this angle is 165, but from this point to this point is 75. Because these are alternating angles, if this is 75, this is also 75 degrees. If this is 45, this is also 45 degrees. And then alternating angles, this is also 45 degrees. 75 minus 90, the whole of this angle is 90. So 75 minus 90 is 15 degrees, which means that 45 plus 15 is 60. So the whole of this angle is 60 degrees. Now we have point P, point Q, and then point R. So let's complete the triangle. Now this 75 degrees is from this point to this point, okay? From this point to this point, not in between the two, okay? It's from this point to this point. Now let's calculate E, the distance of R from P to one decimal place. Now we have this angle to be 60 degrees, okay? Since it's not 90 degrees, we can't use the Pythagoras theorem. We are going to use the cosine rule. So PR square is equal to PQ square plus QR square minus 2 PQ QR cos 60 degrees, cos this angle. So PQ is 12 kilometers, so 12 square plus QR is 20 kilometers, so 20 square minus 2 times 12 times 20, and then cos 60 is 0.5, so times 0.5. This becomes 144, that is 12 square, 20 square is 400, 2 times 12 times 20 times 0.5 is 240. So when you add these two and subtract 240, you'll be left with 304. And therefore, PR will be equal to the square root of 304. And then the distance PR is equal to 17.4356. Now to one decimal place, PR is equal to 17.4. Now let's solve for B. We are going to find or calculate the bearing of R from P. The bearing of R from P. So the bearing of R from P is going to start from this point to the line connecting PR. Okay, so from this point to the line connecting PR. So what we are going to do is, we know this angle to be 45 degrees. Now if we should find this angle, then we can add that to 45, and then we can get the bearing of R from P. So what we are going to do is, we are going to find this angle, the whole of this angle. So let this angle be X. So this is angle X. So using the sine rule, we say that sine X divided by opposite to this angle, we have 20, equals, we know this angle, so we are going to use that, sine 60 divided by opposite to this angle is PR. We are going to use 17.4356. At this point, we can cross multiply. So we have 17.4356 times sine X equals 20 sine 60 is equal to 17.32 0.05. So we divide through by 17.4356, 17.4356, and then we have sine x to be equal to 0.9934. Therefore, x is equal to sine inverse of 0.9934. Therefore, we have angle x to be equal to 83.4 degrees. So that is this angle x. So to calculate the bearing of r from P, then it's going to be 45 degrees plus 83.4 degrees. Therefore, the bearing of r from P is 83.4 plus 45, which is equal to 128.4 degrees. However, we are supposed to leave our answer to the nearest degree, so that is 128 degrees, the bearing of r from P.